I emailed you about turning in Monday.
Okay.
So
I didn't email you, so I have the Okay. Okay, that's fine. Thank you. Yes.
a hard copy or
If you can just also email me the scan form, because I'm, yeah. Okay.
it was with the solution sheet as well.
Okay. Thank you. Okay, everyone, it's 11:30, so I'm going to start today's lecture. So before I start, I'm going to ask you some questions to see if you learned what I taught you in previous sessions or not. And some of these things that I'm asking you during the class and I ask your participation, I'm going to directly ask you in the exam. So I want your full attention. So if I give you this in the exam, and I most probably am going to give you this, saying, is this statement true or false? Is this true or false? Why? Can anyone tell me? Why true, why false? Yes?
True, because if you look at the periodic table of elements, it goes across in terms of atomic mass. And it is increasing.
So if we go back to our periodic table, let's see, I'm pretty certain I had the picture here. Okay. So this is the periodic table. So when I say we arrange the elements based on this property, and when I say we arrange this, it means that, you know, we have like first hydrogen. So when we say that we arrange the element, it means like first here we have, I choose red, hydrogen, and then we have helium, and then we have lithium, beryllium, and boron, carbon, nitrogen, oxygen, fluorine, neon. You see the, you know, this is how we, you know, ordered, or we put the elements, you know, next to each other. This is how we arranged the periodic table. I mean, we didn't do those. We didn't do that, but scientists did, and now we use the periodic table. So now you see what I mean by arranging the elements. So if you look at these atoms, can anyone tell me what is the number that they are arranged based on? What's that? Exactly. So you see this one is like 1, 2, 3, 4. I mean, if you should go to your own book, I kind of like, you know, circle this. So these are like harder to see, you know, but if I just like erase them, I guess, you might be able to see. You see 5, 6, 7, 8, 9, 10, 11 here, 12. You see what I'm going with this? It's kind of, they are arranged based on their atomic number. So atomic mass was what Mendeleev did. And if you think of that, it's not like such a wrong guess either. It has been arranged before based on atomic mass, but right now the periodic table that you have is arranged based on atomic number. So I'm going to ask you this in the exam, and I'm going to tell you whether, true or false. Atomic elements are arranged based on their atomic number in periodic table. So if I say atomic number, the statement is right. But if I say atomic mass, it's wrong. If I say they are arranged based on their charges or any other property, it is wrong. Is this clear now? Okay. So can anyone tell me what is electromagnetic radiation? It seems like my software is frozen. Okay. Now working. Cool. Good. So if I ask you what is electromagnetic radiation? Anyone? Yes? Yes. Light is a form of electromagnetic radiation. So in general, electromagnetic radiation is a type of energy that travels through space at a constant speed of 3 multiplied by 10 to the power of 8 meter per second. And do you remember that we said that this speed is extremely fast? That's why if we have like fireworks, first we see the light, and then seconds after we hear the sound because it's extremely fast. Do you remember these things that we talked about? Okay. And the things, as I said, these things that I'm kind of emphasizing, I'm going to ask you in the test, whether true or false, or say which, I tell you, that is a type of energy that travels through space at a constant speed of 3 multiplied by 10 to the power of 8 meter per second. What is this? And I say it's electromagnetic radiation, that is sound, that is mold, I don't know, the other things that we learned that are not electromagnetic radiation. So is this clear now? So if I show you this picture, or like maybe I write this as a dot, kind of like this. If I show you or give you in the exam this picture, and then I tell you here, I put a question mark and say what is the what question mark represents in the following question. And what is it? Exactly. And then I tell you A is like wavelength, and then is frequency, or is like crest, or is like trough. You see? And do you know what was the definition of wavelength?
The length from crest to crest.
Exactly. Between two consecutive crests. And can you tell me what was the relation between frequency and wavelength? Exactly. So, I'm going to give you two pictures, one like this, and the other like this. And then say which wave has higher frequency. And this is A, This is B. Which one has higher frequency? So why A, why B?
If the frequency is 1 over the wavelength, that is a smaller, a greater portion if it's B, if there's less wavelength.
Yes, so that's one way of explaining that. So the people who said A, why A? So do you remember what was the definition of frequency? Exactly. So if we look at a stationary point, kind of like each of the points that you want to choose, and the number of cycles or crests that pass through that stationary point at any given moment, if it's higher, that means that we have like higher frequency. So, you can also go to YouTube and then watch several videos of this subject, and then you can just see, kind of like in animations, it kind of, you can see it better that if there is a wave going, and then if you consider one stationary point and then count the number of crests or the cycles, you see that with the B, there are like more of them passing through, so it has higher frequency. And I'm going to write the definition again too. That is the number of frequency cycles or crests that pass through a stationary point in 1 second. And you can see why wavelength and frequency are reversed, right? Because if you have a wavelength that is kind of like A, is really long wavelength, if you consider one stationary point, there are like smaller amount of these waves passing through that stationary point. But if it's like, B, there would be much more of those. Does that make sense? Any questions? Good? Okay, so right now you should be able to easily, if you just understood what I just said, you're going to get like 3 questions in your exam, right? Sounds good? Okay. So, on start with 9.93 or like section 9.3, the electromagnetic spectrum. Magnetic spectrum. And if you have questions at any point, just interrupt me and ask the question. So do you also remember what was the components of visible light? Did anyone do the homework? Exactly. So do you remember what were the colors? Exactly. So those colors and that visible light was just like a tiny sliver of the electromagnetic spectrum. So in general, we have like much more, rays and different electromagnetic lights with different spectrum. And then if we put all of them together, we call that electromagnetic spectrum. So to kind of show you what I mean, I try to do a good space management to be able to include all of them. So I think it's beneficial if I just like write this and then explain as I do instead of showing the picture. But I'm going to show you the picture from the book at the end, so you see how prettier that is. Anyway, so depending on, like, do you remember that when you had like your visible light spectrum, the colors that your friend mentioned, each of them had a specific wavelength and frequency and energy associated with it. And if you remember, we said that these different wavelengths determines the color of the visible light. For instance, if we see like red light, red has the smallest energy and the longest wavelength, but blue has the highest frequency, highest energy, and the smallest wavelength. Do you remember? And we said that these different wavelengths determines different colors. And here, for like electromagnetic spectrum in general, we have the same thing. So we have like high energy, we have like low energy, and we have like a spectrum in between. So to give you an idea, the high energy here, it starts with like 10 to the minus 16 meter, and we call them gamma rays. Gamma rays. And the lowest energy belongs to 10 to the power of 6. Exactly. 10 to the power of 6 meter. I'm just trying to follow your book's procedure. And these would be radio waves. And here, let me see, kind of in the middle, if we consider here 10 to the power of minus 5, 7, 9, 11, 13. Okay. So here if it's like, okay, we consider this 10 to the power of minus 15, and then this one 10 to the power of minus 13, minus 11, 10 to the power of minus 9. Yeah, these distances are the same, it's kind of like maybe I didn't do the best job, but you get the point. Minus 1, 10, 10 to the power of 3. Okay, so I'm going to write these with blue. Here, till 10 to the power of minus 1, or maybe I do this one. Okay. We have, okay, from here to here, we have radio waves. From 10 to the power of minus 1 to 10 to the power of minus 3. And you better notice exactly what I'm doing, because I asked you to write this exactly for your homework, and this is how you're going to write it. That would be your microwaves. And now you know that when you put something in your microwave, what spectrum of electromagnetic spectrum you're dealing with. So this is like the radiation that your food is going through when you put it in microwave. And then from 10 to the power of minus 3 to 10 to the power of minus 7-ish, here in between of minus, so kind of like here between minus 5 and minus 7. Actually here, to be exact. Here you have IR, infrared radiation. Infrared radiation. And then this tiny sliver here, that is your visible light that we talked about last week. And continuing with the rest from here to 10 to the power of, not quite minus 9, but close to it, we have UV, ultraviolet radiation. And then from here to 10 to the power of minus 11, we have exactly X-rays. And then here to here, we have gamma rays. So gamma rays here, and then radio waves that I listed here is just like start of the spectrum, but here to here, oops, the whole thing is like gamma ray. So I don't ask you the exact numbers, but I expect you to know these spectrums. So the order of which one has highest energy, which one has lowest energy, and you should be able to sort them based on energy, frequency, and wavelength. So as you remember, frequency and energy, they have like the same trend. So if a specific wave has like higher energy, it has also higher frequency compared to the other one. So they are having the same trend. But wavelength is the opposite. And you always remember that drawing that I had, that if you have like the, do you remember like that frequency, if you have like more waves, more crests in, passing through a stationary point, that it has like higher frequency, but lower wavelength. And then for visible light, here I don't have all the colors to kind of like draw it, and it takes me time. But here you have red, and remember, red is close to infrared, is close to IR, and here purple or like violet, I guess I just write it as your book does, is close to ultraviolet. So this is how you can remember that where they are located in the spectrum. So red is close to IR, infrared, and then violet is close to ultraviolet, UV. Does that make sense? So any question about this spectrum? So I asked you in your homework, to exactly write this. So you know that, radio waves have the highest, wavelength, and they have like the lowest energy. And then you have like microwave, IR, visible light, UV, X-rays, gamma rays, and that's it. Any question about that? Yes? Yes. So, in this spectrum, when you are on the left side, or when you approach the left side, you have like the lowest energy and lowest frequency, but you have the highest wavelength. And you can see it from the number here too. It's like 10 to the power of 6. That is a really long wavelength. But gamma rays have like 10 to the power of minus 16 meter. It's really, really small. If you write this number, it would be like 10 to the power of minus 16 is basically 1 over 10 to the power of 16, and then 16 of this. So it's basically 0.00000001, and then 16 of this. You see that this is extremely small wavelength. And that's why if you want to know which one of these radiations, because, these radiations we encounter in our daily life, right? When you go, to get tanned near the beach, it's kind of that people say, or like scientists, doctors, or like your friends say that you should wear sunscreen. Do you know why you wear sunscreen?
The radiation?
Yes. Do you know what type of radiation? Exactly, UV. So that is located here. So if you don't wear sunscreen, and then you just go, get tanned over and over and over again without sunscreen over a period of time, you may get skin cancer, God forbid. But that is the reality of it. That's why you should wear sunscreen, because UV light is proven to cause cancer. And also X-rays, and you can see where I'm going with this. When you go to the right, these radiations are more and more dangerous. And if you break your bone, and or for some other medical reasons, you go to the doctor and they want to take an X-ray. So if you just expose to it 1, 2, 3 times, that's fine. But if you notice the technician that does that, they leave the room, right? Because if they would be exposed by X-ray over and over, they would, get cancer or other diseases too. So it's, dangerous. Limited exposure doesn't do anything because, if you one time go to the beach, forget sunscreen, most probably nothing happens to you. But over and over exposure to it is dangerous. The same thing with X-rays. So that's why you should be careful to not break your bones all the time, I mean, still, you most probably would be fine. But as I said, the technician, they would leave the room because they shouldn't be exposed to radiation, X-ray radiation over and over again. And then gamma rays are like the most dangerous one because they have the highest energy and highest frequency. And they can damage the biological cells. So they are like even more dangerous than the other two that we mentioned. So now remember, gamma rays are the most dangerous ones. They damage biological cells, and then X-rays are bad, and then like ultraviolet, UV. And now I think, you could remember these three, right? It's kind of like gamma rays are the worst, and then X-ray. And then you can remember why they are bad, why they are damaging, because they have high energy. And then you can remember that microwaves, you use them every day, right? If they were really dangerous or like had high energies, we wouldn't use them, right? And they were like, I don't know whether your generation heard of it or not, but when we were growing up, my generation, they were like this big controversy that are microwaves good or bad? And then because they just came out and people were thinking they have like electromagnetic radiation, so they are cancerous, they are bad, we shouldn't use them. But based on this explanation, and when people would ask like scientists and doctors in like different TV shows, they would say this is we should go to the lab experiment and then see whether or not they are dangerous. And so far there is no studies, or like I'm not aware of, saying that microwave is bad because they have like much lower energy. And then radio wave, the FM, AM, in television, cell phones, they use radio waves. So they have like the longest wavelength, lowest energy, so they are like the safest. And we covered almost all. And visible light, is not dangerous. This is the reason that we can see, right? Is this clear? And then lastly is like IR and infrared radiation is basically anything that is hot, it produces IR radiation. So if you have a hot plate and then anything that you can sense warmth, it has IR radiation. So that relates to heat. And again, it's not dangerous, but it's been used to take photographs at night so that is one of its application. And I have the picture from your book to kind of demonstrate this. So here is a photograph taken by IR camera. And you can see that you see the difference because it's based on heat. The places that are like warmer, like human bodies, has like red, but the places that are cold, it shows blue. So this is one application of IR. And we covered most of the things here, but again, remember gamma rays, they can like damage biological molecules, and then X-ray. And as we said, if they are relatively harmless, but excessive exposure, it has, increased risk of cancer. And then again with UV, ultraviolet, and we said that, they do not damage biological molecules, but if they are like, this is like UV. So as we said, UV is harmless, and then IR, and then radio wave microwaves. So kind of like showing you the book and then how it is structured, and I wanted to show you this picture. So any question about any of these waves? So if I tell you which one of the following, and I'm going to ask you this, so I'm giving you another question of your exam. I'm going to change the, rays or like this specific, electromagnetic radiations, but the type of the question is the same. Which of the following has the least energy? Gamma rays, UV, or IR? Ultraviolet or infrared, or gamma rays has the least amount of energy? Exactly. And then you can, again, remember which one is most dangerous, kind of like to know which one is which. Any question or anything that we talked about? Very good. So now I'm going to talk about something called photon. So as we mentioned, and we talked about, we said that light is a wave, right? We said like electromagnetic is an electromagnetic radiation, and we said it has a wavelength, it has frequency, it has energy. But there were some experiments, when scientists were doing some experiments, they had like some data that they couldn't figure out the reasoning if they would consider light as a wave. So that's where in some experiments they realized that they can interpret the results only if they consider light as being a particle. And that was a really revolution in science. And for instance, Albert Einstein was one of the people that discovered that light not only is a wave, is also a particle. And that is where we have the definition of photon. So this is, we define, or I write it with black, a particle of light is called photon. And we can think of a photon as a single packet of light energy. So is this clear? So what is a photon? Yes? Exactly. And the amount of energy that this particle of light has depends on its wavelength. I'm going to also write this. The amount of energy carried in the packet depends on the wavelength of the light. And as we said, the shorter the wavelength, it has like higher amount of energy, right? The longest the wavelength, it has like the lowest amount of energy. Is this clear? So this is really important to remember that light is both considered as being a wave and also a particle. Kind of like, stream of particles. So if you look at the light, it's as if there are like a stream of particles coming. And also a wave of particles. Is that clear? Any questions? Okay, if no question, I'm going to have the first series of homework questions. So I already wrote them, so I saved some time, but I'm going to read them for you. So the first question is that draw the electromagnetic spectrum. So what I just did, and if you paid attention, it should be kind of easy to do so. So clearly write the names of different rays, or like different wavelengths, and clearly write their wavelength. Kind of like, if you had like 10 to the power of minus 15 to 10 to the power of minus 16 to 10 to the power of 6, right? Highest energy, lowest energy. Clearly specify their energy, frequency, and wavelength trends. So what I'm saying is that when you write these, trends, I want you to write, for instance, here, you say that this is like lowest or like low energy, doesn't write, I'm just going to a high. This is like high energy. And then the same thing with frequency, and the same thing with the wavelength. So specify which one has the highest wavelength and kind of know their position. Does that make sense? Any question about this? The first question? Clear? And then number 2, which of the following has the highest energy? Gamma rays, UV, microwaves, visible light. And you're going to see a question similar to this in your exam, that whether I say which one has the highest energy or like highest frequency or like lowest energy, lowest wavelength. So if you just learn that graph that I draw, or like that picture that I draw, spectrum, you should be able to answer this question too. Is everyone good with this? Can I just go to the next page, or are you still writing? Yes? UV. Sorry. It's kind of like UV. Yeah, thank you. Anything else? Can you read this? Okay. So just something I thought to just ask right now. For your previous exam, I gave you 40 questions. So for your next exam, and something that some students asked me, that is the exam 4 still on Friday after the break? So kind of like, I'm following Professor Stelz's schedule. So all your exams, basically, at this point you have quiz 4, exam 4, and final exam. They are like the exact dates that is specified. So we're following that schedule. But I'm not going to cover chapter 11 because I cannot, simply. So, but other than that, everything else is the same. Yes? Question? Okay, are we good with this? Can I go to the next page? Okay. Okay, so these are like some more questions, and the reason I'm giving you more questions is that you can have more extra points, and then you see what you're going to see in your exam too. But as I said, if you know that the spectrum, all these questions will be fairly easy. So the number 3 says sort the following based on their wavelength. And it's microwaves, radio waves, X-rays. And then just like say, from highest to lowest, or just like specify which one is the highest, which one is the lowest, which one is in between. Kind of like just somehow that I understand what is your trend, right? And the other one is that arrange the 3 types of electromagnetic radiation, visible light, X-rays, and microwaves in order of increasing wavelength, frequency, energy per photon. Okay, while you guys are writing this, so in exam 3, I gave you 40 questions. Do you prefer having 40 or 25? So first I asked 40. How many people want to have 40 questions in exam and they think that they were fine with the time and everything? Can you raise it a little higher? Okay, 22 people. So how many think, so these are like 40 questions. So how many think that having 25 was better? Okay, much more, I see. I guess, just keep it up by count to be sure. Okay, almost like 36, okay. So for your exam 4, this is something that I heard from some students and also I thought maybe causing stress. The reason that I did that, I wanted you to have more questions so that you don't lose like 5 points or like 4 points for one wrong answer. But what I'm going to do for your exam 4, I'm going to give you 25 questions. So you have like, you don't have to rush through the answers or like have stress. Any question about that? Yes?
Wait, so if it's 40 questions, 25 questions, is it going to be like the same difficulty as the questions from the 40 like as the questions that we got when we were taking the 40 question test? Or
so I tried for 40 questions to be like some of them really straightforward, so it would be like the same amount of difficulty. So it would be the same. But probably I have like, I try to ask from the things that I'm directly telling you in the class, which I'm going to post in the study guide, so it won't be, you won't be seeing anything that we didn't talk about in the class, if that makes sense. So I already in this session and previous sessions, one of them was like combustion reactions. Which one of the following is not a combustion reaction, right? Or like, I designed them mostly from your homework problems, what I'm telling you in the class, and things that I emphasize. So hopefully it won't be super difficult or like it won't be anything new. As long as you listen to the lectures and do the homework, I think you should be in good shape. And I think we'll see in exam 4 how that would be. Any other questions? Okay. So now that I'm going to, so any questions about electromagnetic spectrum and different radiations, different frequencies, wavelengths, is this clear? So which one, now I'm going to see if you're actually learned or not. Which one has the highest energy? Gamma or, yes? Oh, okay. Yeah. Good. So between these, like UV, ultraviolet, or visible light, which one has the higher energy? Yes?
ultraviolet.
Great. So between visible light and microwaves, which one has the lowest energy? Lowest energy.
Microwave.
Yes, now I'm kind of like feeling like the host shows, like when people ring and then someone answers. Okay, so we're good with that. Okay. So now I'm going to talk about, I didn't mean to use this. Okay. Bohr model. Atoms with orbits. So you see that when we talked about visible light, and we said that if we pass visible light through a prism, we can see a spectrum of different colors. Do you remember? And we said that is continuous. So you cannot exactly, see here is blue, here is violet, or like here is orange, this is red. It's kind of like a spectrum, and the color changes gradually, is continuous. But when we have different atoms, they can absorb energy. And it's been proven, it's been seen by scientists that when atoms absorb energy, they will then emit the energy. But unlike visible light that we see a spectrum which is like continuous, for atoms we just see like single lines. And what I mean, probably I will demonstrate the best with showing you a picture from your book. So here is your book, and you can see the page and also the section for your reference when you want to go back, look at it. You see that if you have, like, for instance, a neon sign, how many of you have ever seen a neon sign? Yeah. So you see that these are actually, they have like neon element in them. And as you remember, we said neon is a noble gas, right? And if, they have they are plugged into electrical energy, and after they absorb that electrical energy, they emit light. And depending on what we have, so in this case, neon light, we have neon, obviously. But if we have other elements, for instance, here we have a mercury lamp here on the, I was so close to play again, last session. I'm so glad I didn't. Okay, so mercury lamp here we have on the left, and then we have hydrogen lamp on the right. So depending on what element we have different color. And remember, different wavelengths are associated with different colors. So before I go to the next picture that I have, any question about this? So right now I told you that elements absorb energy and they emit energy, and depending on what elements they are, it would be different color, right? Questions? Okay, so here we have more scientific way of showing what I just showed you in the previous picture, that if we have the hydrogen lamp, for instance, that you saw in the previous picture, and then we pass it through a slit and then a prism, we can see an emission, a spectrum of hydrogen. So it's kind of the same thing as visible light, that we had a prism, and then we would see a continuous spectrum of colors. But for hydrogen here, you just see few lines, right? Here you have the horizontal picture, and you see the difference, right? For white light spectrum, and this is another thing that I'm going to give you in the exam. I have a picture, I say, which of the following can be an element? And I give you this picture and this picture or this picture. So if you see individual lines but not a continuous spectrum, that corresponds to exactly. But if you see a picture like this, which is a continuous spectrum, that is visible light, right? That is not an element. So this is really important. And this is something to remember, that for each element, you have a unique spectrum. So that's how we can distinguish different elements. For hydrogen, you have 3 of these lines. But for helium, you have 5 of these, or for neon, much more. So this is actually like fingerprints. For each element, you see a specific spectrum that distinguishes that from the other element. Any question about what I just said or like these concepts? So these are really important to understand the Bohr model that I'm going to talk about in next class. Yeah. Yes. Yeah, of course. Yes.
I didn't get back to you this weekend. I turn in, I have all the homework done. I turn them in, will you still accept them? Once you guys-
Yes, but just upload them in the user.
Okay, and I'll make sure to re-email you and explain it.
Okay, perfect.
Take care.
I was just curious because we have my flights worked out for when I come back from Thanksgiving.
Uh-huh.
I'm gonna miss Wednesday, so I won't be able to turn in my quiz. Would it be possible if I could just email you?
Yes. Yeah.
Thank you so much.
Of course.